My name is Jalen Hasward. This is my week 4 heat presentation. A quick informative presentation just discussing heat, temperature, thermal energy, all the measures of temperature regulation across the world, and so on. So let's take a look into that. So the first slide I have is what is heat? So in my definition, I have it defined as the transfer of thermal energy from one object or system to another due to the overall difference in temperature. I did note that it can only happen when there is a temperature difference. I threw in the different kinds of measurements that are there. I did also note that heat is energy in motion. I think that point is extremely important. I thought of describing it as something like money being transferred between bank accounts. I feel like the account that contains energy, which is thermal energy, but the transfer itself is heat, if that makes sense. So down here, I mentioned that it also consists of conduction, convection, and radiation. Radiation is like electromagnetic waves, convection is like fluid motion, and conduction is like a form of contact. Next, we have what is thermal energy. So I have thermal energy defined as the total internal energy of a system due to the random motion and vibration of its own atoms and molecules. I think the best way to compare it to a real life example to make someone grasp it if they've never heard of it is to compare it to someone or a crowd of people almost. I feel like thermal energy is the total combined energy of everyone moving all at once, maybe in a setting like people dancing, if that makes sense. I did include information such as it depends on how fast particles are moving and how many particles there are. It does increase when the particles move faster or when the mass of the object increases. And I also noted that it can be transferred with conduction, convection, and radiation. I thought a couple real world examples that made sense to align with our pictures are heat from a stove as well as heat from a fire, say for having a campfire or something that's close. Next, we have temperature. I feel like temperature is probably the most well known and well regarded one just because it's so common that it goes into nearly everything that has to do with maintaining heat or cold, whether it's stepping outside or making sure that food is cooked to a certain temperature or frozen to a certain temperature to be safe. The official definition I have is the average kinetic energy of particles in a substance to determine how hot or cold something is. It does not depend on how much of the substance you have, and it can be measured in Celsius, Fahrenheit, as well as Kelvin, and we'll take a look at that in a bit. Higher temperature does mean faster moving particles, and two objects can have the same temperature but different amounts of thermal energy. Temperature is what thermometers measure. That's an important tool. So, talking about temperature, I wanted to take a little bit of a deeper dive. So, here we have Celsius on the left, Fahrenheit in the middle, and Kelvin at the end. Celsius is kind of the global go to. I know we live here in the United States, but if you anywhere else, perhaps Europe or somewhere in Asia, that's generally their go to. The United States is pretty adamant about staying on the Fahrenheit measure, but Celsius is generally the way to go. So Celsius is the global go-to with the freezing point being 0 degrees and the boiling point being 100 degrees. Fahrenheit, which is the United States of America and a few other countries, I believe it's about 7 or 8. I have it on the next slide. Our freezing point is 32 degrees, and the boiling point I found is that it's 200 degrees Fahrenheit. Kelvin, on the other hand, it's the scientific scale. It just means that there are zero negative temperatures on the Kelvin scale of measurement. I have a couple images here that describe how those should look. Fahrenheit is here on the left, Celsius is in the middle, Kelvin is right here on the right. A couple similarities and differences when it comes to the three are just simple aspects. They all relate to kinetic energy. They all help explain heating and cooling. They are all a part of thermal energy systems. That's the important part. They are all a part of thermal energy systems. There's a few slight differences. I'd say more than slight, actually. They are pretty notable and they all give them their own unique characteristics and factors, such as temperature being the average particle motion, thermal energy being the total particle motion, and heat being the energy transfer. Just like that example I mentioned earlier, when you're moving money from a bank, that's kind of where heat aligns. So, the last aspect that I wanted to touch on is what countries use Celsius and Fahrenheit because I found that pretty interesting. So, according to the World Population Review, a majority of the various countries across the world use Celsius as a unit of temperature measurement. The countries that use Fahrenheit to this day are the United States, the Bahamas, the Cayman Islands, Palau, the states of Micronesia, and the Marshall Islands. I did also find that there's a couple countries that, for reasons I'm not too sure of, they end up using both measurements. Maybe it's something of integration or something along that aspect. It's just a couple. It's a few. It's Belize, Bermuda, and the British Virgin Islands as well. And these are just my references. I got the definition for heat from Cambridge Dictionary as well as our textbook. Countries that use Fahrenheit comes from the World Population Review as well as what uses Celsius. And the whole aspect of thermal energy and temperature I got from LibreText, which is a great chemistry and science related website. Thank you.